Good morning, everyone. Is my voice audible to all of you? Can you just confirm? One of you?
Yes,
Okay. So, good morning, everyone. My name is Tanushri, and I'll be teaching you analysis. And today's topic is nephelometry and turbidiometry. So, this is, I think, your first interaction with me. So, I would like to introduce myself. So, my name is Tanushri Das, and I did my M.Pharm in analysis from Principal K. Kundanani College of Pharmacy. I'm Gpat qualified and I'm a pass out of 2017, and currently I'm working for McLeod's Pharmaceuticals as a research associate in bioanalytical department. So which year students are you? Yes? Let's have some interaction. One of you can tell me which year students you are? Which year students? Am I not audible or what? Can you hear me? Hello?
yes, ma'am.
हाँ कौन से ईयर के बच्चे होते हो
Second year.
second year so are you familiar with nephelometry and turbidimetry let's have an interactive session because if we don't interact and talk to each other while the presentation is on then the lecture will get boring for you so I want every student to participate actively and if you are not understanding anything या कोई भी slide में तुम लोगों को कुछ भी समझ में नहीं आ रहा immediately you can pause me and मुझे पूछ सकते हो अपना mic unmute करके. So is it fine if I teach in both English as well as Hindi or you want only Hindi? Come on students interact.
Both languages.
Both is fine, okay? Okay. Anyone has any idea कि नाम से कोई बता सकता है nephelometry and turbidimetry क्या हो सकता है? With the name turbidimetry, which something that comes across your mind, anyone? Let's have an active discussion. Even if it's wrong, it's fine because this is a new topic. We are learning it. So let's have an interactive session. टर्बिड का मतलब क्या होता है कोई मुझे बता सकता है टर्बिडिमेट्री क्या हो सकता है ऑफ कोर्स इट इज एन एनालिटिकल टेक्निक बट व्हाट इज इट बेस्ड ऑन लुकिंग एट द नेम एनी वन ऑफ यू सिंपल है टर्बिडिमेट्री मतलब तुम्हारा जो भी सैंपल सोल्यूशन रहेगा उसका टर्बिडिटी कितना है टर्बिडिटी क्यों होता है कोई भी सोल्यूशन में कैन एनीवन टेल मी लेट अस स्टार्ट विद अ वेरी बेसिक इंफॉर्मेशन सोल्यूशन टर्बिड कब होता है एनीवन Ricky, can you please order? Hello? Can you be a little louder? Your voice is still breaking. I cannot hear you. Or you can write in the chat also. Type करके भी बोल सकते हो. Anyone else? Because I cannot hear you.
Cloudiness.
Cloudiness. But why is that cloudiness there in your solution? क्यों होता है? Very basic. First of all, to learn this analytical technique, you have to know what is turbidity. Okay, fine. I will tell you. Whenever there are undissolved suspended particles in your solution, it will result in cloudiness and will be result in the turbidity of the solution. अभी कोई भी अगर चीज अच्छे से डिसॉल्व नहीं होता है टेक फॉर इंस्टेंस योर वाटर You have water, and if you have added maybe some powder, Horlicks. So you know Horlicks completely dissolve नहीं होता, like how sugar is completely dissolving in water. You can see a milky solution in your Horlicks. If you're dissolving Horlicks powder or Bonvita in water, you can see there is color, and there are some suspended particles of the Horlicks powder in it. So completely dissolved नहीं हुआ है. So only those components which are soluble will dissolve and will give you a clear solution. So that is how you get a clear solution. But if there are certain particles in your solution which are not completely dissolving in it, then turbidity is formed. That is the reason why you have cloudy solutions. So whenever कोई भी तुम्हारे particles suspended रहेंगे in an undissolved form, then your solution is said to be turbid or cloudy. Is it clear? Now, what is actually turbidimetry and nephelometry? अभी मैंने ये तो बोला कि तुम्हारा solution क्यों turbid होता है, लेकिन ये turbidity होने के पीछे reason क्या हो सकता है? Like, why do we need to measure the turbidity? Can anyone tell me just a general idea कि हम ये turbidity को क्यों measure करेंगे? हमें क्या फायदा होगा ये turbidity measure करके? Anyone of you? You can write it in the chat also if you're not comfortable speaking on the mic. Okay, I have a chat. Water quality, yes, Chetan, you have given the right answer. We can check the quality of water, but also you have certain blood products like you have serum, you have plasma, and in blood you have different types of immunoglobulins, which is IgG, IgA, IgM, IgE. Then you have C-reactive proteins, albumins, haptoglobins. तो ये सब जो चीजों है ना, ये हम लोग नेफेलोमेट्री एंड टर्बिडिमेट्री से आइडेंटिफाई कर सकते हैं. व्हाई? बिकॉज इन ब्लड प्लाज्मा दे आर नेवर इन soluble form. They are actually present are suspended in the blood plasma. So you can quantify or you can identify the amount of immunoglobulins in the blood or plasma that is there by simply using this analytical technique. So this is one of the applications in your bio, like when you have to identify biological samples. Now, when you have to identify solubility or maybe saturation of any solution in pharmaceutical point of view. Now, suppose I have a tablet solution. You all know that tablets are made from active ingredients as well as the excipients. So it is the active ingredients that are solubilized, they are absorbed in the body, they are digested, they are assimilated, they are distributed, then they reach the pharmacological site of action, they give you the required pharmacological activity, and then they are eliminated by first pass metabolism. तो हम लोग इससे आइडेंटिफाई करते हैं जब हम कोई भी सोल्यूशन, जैसे कि नाउ वी हैव टू मेक अ डिस्पिरिन सोल्यूशन. यू ऑल नो दैट डिस्पिरिन इज डिस्पर्सिबल टैबलेट. जब तुम उसको पानी में डिस्पर्स करते हो, so a solution is formed which is easy to drink rather than swallowing the tablet, and it gives a quicker action because it is dispersible in the water. तो वो जो excipients का है, जो dispersion हो रहा है, तो उससे हम अमाउंट क्वांटिफाई कर सकते हैं कि हमारे टैबलेट में कितना. यू कैन बेसिकली आइडेंटिफाई द क्वालिटी ऑफ योर फार्मास्यूटिकल फॉर्मुलेशंस. नाउ यू हैव सस्पेंशंस लाइक यू हैव जेल्यूसिल, वो लोग भी सस्पेंशन फॉर्म में ही रहते हैं. तो कितना कोलोइडल पार्टिकल्स है, पार्टिकल साइज क्या है तुम्हारे सोल्यूशन का, ये सब क्वालिटी कंट्रोल का एक हिस्सा होता है. Because you have to regulate the particle size in your pharmaceutical formulations or solutions. Abhi, you cannot keep lump of drug in your gelusil solution. Then there will not be uniform distribution of the drug in the entire bottle of gelusil. So it is very important that a proper uniform particle size of the active ingredients is maintained in your suspension. So that is why when they say you have to use a suspension or emulsion anyway, you have to shake it well before use. So because all the particles settle down. So when you shake it well, that time all the particles are uniformly distributed. And then when you are taking the required dose, maybe 5 ml, 10 ml, 15 ml, तब we can have a fair idea that the patient is having an equal distribution of the medicated ingredients in the suspension. If all the particles are settled down और वो सिर्फ एक्सिपिएंट्स का पानी पी रहा है तो उसको तो फार्माकोलॉजिकल नहीं मिलेगा. So it is very important that a proper suspension is maintained. कि ज्यादा अगर ज्यादा हैवी पार्टिकल रहेगा तुम्हारे इसमें सोल्यूशन में जेली में तो वो नीचे बॉटम में सेटल हो जाएगा फिर उसको रिकॉन्स्टिट्यूट करके फिर उसको मतलब मिक्स करने में प्रॉब्लम होगा सो दीज आर ऑल पार्ट ऑफ क्वालिटी कंट्रोल टेस्ट सो फॉर फाइनल फॉर्मुलेशंस आल्सो यू विल यूज these techniques to determine the particle size and also to see the uniform distribution of the particles. Is it clear till now? Any doubts? Why we will be doing this? Yes, students? No doubts, right? Can I proceed? I'm assuming that you're not having any doubts because nobody is interacting. Can we please interact, students? I should also know whom I'm teaching. समझा सबको? Proceed करूँ? Am I audible to you? Okay. Next. अभी नेफेलोमेट्री टर्बिडीमेट्री ये दो टेक्निक मैं जब साथ में तुम लोगों को सिखा रही हूँ सो देयर मस्ट बी अ रीजन व्हाई आई एम डूइंग नाउ देयर आर टू बेसिक प्रिंसिपल नेफेलोमेट्री में क्या होता है इंटेंसिटी प्लीज लिसन टू मी केयरफुली इंटेंसिटी ऑफ स्कैटर्ड लाइट इज मेजर्ड while in turbidimetry intensity of transmitted light is measured. मतलब क्या होता है नेफेलोमेट्री में क्या होगा बिकॉज ऑफ द वेरियस पार्टिकल्स दैट आर देयर इन योर सोल्यूशन तो जब तुम लाइट को इंसिडेंट करोगे तुम्हारे सैंपल पे तो देयर विल बी अ फेनोमेना कॉल्ड एज द स्कैटरिंग ऑफ द लाइट स्कैटरिंग ऑफ द लाइट क्यों होगा क्योंकि वो पार्टिकल्स जो है वो लाइट के पाथ के बीच में आ रहे हैं तो उसके वजह से एक स्कैटरिंग फेनोमेना होगा तो वो स्कैटरिंग फेनोमेना को जब हम मेजर करेंगे दैट टेक्निक इज कॉल्ड एज नेफेलोमेट्री और टर्बिडिमेट्री में क्या होगा because of the particles that are present in your solution some of the light will not be trans it will not be in it when it is incident on the sample it will be transmitted and not absorbed so part of the light will be absorbed and part of the light will be transmitted now wo light क्यों transmit होगा obviously because of the hindrance of your particles that are present in the solution तो टर्बिडिमेट्री में हम जो लाइट ट्रांसमिट हो रहा है उसको मेजर करेंगे और नेफेलोमेट्री में हमारा जो लाइट स्कैटर हो रहा है उसको हम मेजर करेंगे so you can see here it is written here we'll go back to the slide I'll put my laser on just a second okay so what happens when an electromagnetic radiation which means simply light strikes the particle in the solution some of the light will be absorbed by the particle while some will be transmitted through the solution and some light will either be scattered or reflected. The amount of light scattered is going to be directly proportional to the concentration of the insoluble particle. So we will focus on the concept of light scatter in terms of nephelometry and the concept of light transmitted in terms of turbidimetry. Is it clear? Basic principle? Clear everyone? Yes or
Yes.
no? Okay. अभी क्या होता है scattered light may be measured by two phenomena as I said जब transmitted light को measure करोगे तो वो turbidimetry होगा जब scattered light को measure करोगे उसको nephelometry बोलेंगे in turbidimetry the intensity of light transmitted through the medium that is the unscattered light is measured are you getting it ये term सबको समझ में आ रहा है यहाँ पे लाइट ट्रांसमिट हो रहा है लेकिन फैल नहीं रहा स्कैटर नहीं हो रहा इन टर्बिडिमेट्री so in turbidimetry the intensity of the light which is transmitted through the medium now you can see this is a light source we have a lens this is a sample cell where you have your sample solution तो क्या होगा जब तुम 90 डिग्री पे ये सैंपल सेल को घुमाओगे तो क्या होगा some of the light will be scattered. So that scattered light will go undetected क्योंकि ये टर्बिडिमेट्री है, हमें स्कैटर्ड लाइट से लेना देना नहीं है. हमें कौन से लाइट से लेना देना है? सैंपल जो ट्रांसमिट हो रहा है वो लाइट से लेना देना. तो ये सैंपल में से जो ट्रांसमिटेड रेडिएशन बाहर निकलता है वो ये लाइट डिटेक्टर डिटेक्ट करता है. दिस इज अ सिंपल ब्लॉक डायग्राम फॉर एक्सप्लेनेशन. So when electromagnetic radiation is put on your sample through this source, lens के through वो concentrate होगा तुम्हारा light radiation, and that particular wavelength of radiation, when it will reach your sample, some of the light will be absorbed, part of it will be scattered, and at 90 degrees, part of it will be transmitted. So in turbidimetry, we are only going to measure the transmitted light. And from the transmitted light, we can find out the concentration, or we can quantify the amount of insoluble particles that are there in your sample. Is it clear? Sabko samjha? Any doubt? Now, turbidometric measurements are made at basically rotation of 180 degrees from the incident light beam. And in nephelometry, the intensity of scattered light is measured usually at right angles, that means 90 degrees. Please keep this in mind. Turbidometric measurements are made at 180 degree. मतलब incident light जब गिरता है तुम्हारे sample पे, तो 180 degree को वो sample rotate होता है, and at 180 degree the range is kept a little wide by 180 degree because we have to measure the light transmitted. So light transmission करने के लिए तुम्हें 180 degree angle की जरूरत होती है. So that is why in turbidometric measurements we use a 180 degree angle. That is, we operate the instrument at 180 degree angles from the incident light beam. While in nephelometry, we are only interested in the scattered light. We are not interested in the absorbed or transmitted light. So light scattering phenomena can occur at 90 degrees also. So that is why in nephelometry, a 90 degree operating angle is sufficient for analysis. So is it clear? Any doubts? इतना समझा why we are operating at 180 degree for turbidometric and for 90 degree at nephelometric analysis. Yes, chat में बताओ मुझे 2-3 students that you have understood. Okay. So Vishal says that he is understood. So I think Chetan and Vishal are the only two active students I can see. Okay, I have got a reply to Vaishnavi. Okay, good. So let us proceed now. Now, turbidimetry deals with the measurement of the intensity of transmitted light, while nephelometry deals with the measurement of incidence of intensity of scattered light. Now, there are various factors that are also going to affect these analysis. Now, these two techniques only differ in the manner of measuring the scattered radiation. As I said, 180 degree pe you will measure for turbidimetry, and 90 degree pe you can see here you will measure for nephelometry. So that is the difference in the two techniques. And majorly in turbidimetry, transmitted light is measured. In nephelometry, or scattered light is measured. Now, turbidity can be measured on the most routine analysis by a spectrophotometer. So, what is the job of the spectrophotometer? The job of the spectrophotometer is to analyze the transmitted light or the absorbed light. It can either operate in either way. अभी absorbed light को भी उसने measure किया तो हमें पता चल जाएगा क्योंकि when we are subjecting a particular wavelength of light to your sample, हमें पता है हम कितना wavelength तुम्हारे sample को supply कर रहे हैं. तो उसमें से अगर कुछ हिस्सा absorb हो रहा है और हम वो absorb the light को detect कर रहे हैं, so it is understood that the remaining part of the light which is not absorbed is transmitted. And if the spectrometer is detecting the transmitted light, मतलब जितना transmit हुआ है सिर्फ उतना ही measure कर रहा है, then also we can find out the amount of light absorbed. So hence, because of this phenomena, we are able to identify or measure your transmitted radiation. Now, in turbidimetry, their sensitivity and precision is comparatively less than that of the nephelometer because extent of light increases as wavelength increases. Means what? अगर तुम ज्यादा wavelength का radiation supply कर रहे हो, तो light scattering phenomena जो है वो ज्यादा increase हो जाता है. So then the sensitivity and the precision of the method becomes less. मतलब वो ज्यादा कम accurate हो जाता है. And the accuracy is little bit hampered because of the excessive light scattering that is there. So So in turbidimetry you can operate at lower wavelengths क्योंकि जितना lower रहेगा तुम्हारा wavelength तो उतना कम scattering होगा. Why? Because we are operating on 180 degree. तो light को ज्यादा scope है scatter होने का. तो जितना ज्यादा लंबा wavelength लोगे उतना ज्यादा light scattering होगा. और लाइट नेफेलोमेट्री में क्या होता है, यू आर ऑपरेटिंग एट 90 डिग्री, सो द इंटेंसिटी ऑफ स्कैटर्ड लाइट इज मेजर्ड एंड ट्रांसमिटेड लाइट इज नॉट मेजर्ड. तो इसमें जितना ज्यादा स्कैटरिंग होगा नेफेलोमेट्री में उसको डिटेक्ट करने के लिए उतना ज्यादा इजी होगा. बिकॉज नेफेलोमीटर is going to detect your scattered light only. It has no relation with your transmitted. So that is why nephelometer technique will be able to identify the scattered light much more precisely and compared to your turbidometer. Okay, is it clear? Any doubt? Shall I proceed? इतना समझा सबको?
Yes,
Yes or no? Okay. So light scattering is the physical phenomenon resulting how because of the interaction of light with obviously the suspended particles in your solution. Now, various factors can affect this phenomena. So which are the factors that can affect this phenomena? Chetan, I will repeat again. You did not get it. I got your message. So just pay attention as I proceed with the slide. The concept will get clear to you. Okay. Now light scattering के now अभी light scattering obviously कौन से factors पे depend होगा. एक तो particle size, एक wavelength, distance of observation मतलब मैं कितना दूर खड़ी हूँ वो solution से और मैं visibly कितना उसको observe कर रही हूँ. So that distance of observation I'm talking about. So that can also affect. Also the concentration of the particles as well as the molecular weight of the particles. Now, how are all these factors going to play a role in your analysis? I will tell you as we proceed with the slide. And Chetan, your doubt is, ये देखो क्या होता है? What I meant in this slide is that turbidometric measurements जो है वो nephelometry से जरा कम precise है. You all understand precision and sensitivity. Sensitivity मतलब क्या? जितना lower concentrations पे तुम्हारा analytical technique तुम्हारे एनालाइट को डिटेक्ट कर सकता है उसको सेंसिटिविटी बोलते हैं. सेंसिटिव मतलब क्या? जित मतलब कम से कम कॉन्सेंट्रेशंस को भी वो आइडेंटिफाई कर सके. सो दैट इज कॉल्ड एज सेंसिटिव. So the sensitivity of turbidometric measurements is comparatively lesser compared to nephelometer. Q, there is a reason for that because you're operating at a 180 degree angle in turbidimetry. तो जितना ज्यादा एंगल वाइड है तुम्हारा उतना ज्यादा लाइट स्कैटरिंग फिनोमेना होता है. और ये लाइट स्कैटरिंग फिनोमेना कब ज्यादा होगा? स्पेशली व्हेन यू आर गोइंग टू ऑपरेट एट हायर वेवलेंथ. अभी जितना ज्यादा वेवलेंथ होगा लाइट का उतना ज्यादा उसका स्कैटरिंग भी बढ़ेगा. तो turbidometric measurements will be less sensitive when you are operating at higher wavelengths. But in nephelometer, that is not the case. You can operate at both higher as well as lower wavelengths. Why? Because यहाँ पे हम scattered light measure कर रहे हैं और हमारा operating angle is also less narrow compared to 180 degrees. तो 90 डिग्री पे we are doing the analysis for nephelometer. तो जो स्कैटरिंग होता है वो 90 डिग्री एंगल पे ही लिमिटेड होता है और हमें नेफेलोमीटर में ट्रांसमिटेड लाइट और एब्जॉर्ब लाइट का मेजरमेंट नहीं करना होता है. हमें सिर्फ और सिर्फ स्कैटर्ड लाइट मेजरमेंट करना होता है. दैट इज व्हाई नेफेलोमेटर measurements are comparatively easier to do and they are comparatively more precise than turbidimetric measurements. Now you understood, Chetan? Yes. I'm waiting for your confirmation, Chetan, that you have understood. Okay, so let us proceed now, students. Abhi, there is an effect called as Tyndall effect. So the Tyndall effect is a name for a very simple phenomenon which is called as a scattering of light. तो ये Tyndall effect इसको याद रखो क्योंकि it will be important with Gpat point of view. So they might just ask you questions like what is Tyndall effect or in which solutions can Tyndall effect occur. So if you don't know what is Tyndall effect, then there will be problems when you will be solving your MCQs. It is very simple. Scattering of light Scattering of light by particles in a colloid or suspension called as Tyndall effect. मतलब क्या, तुम्हारे सोल्यूशन में जो भी सस्पेंडेड पार्टिकल्स और कोलॉइड्स है उसके वजह से लाइट जब स्कैटर होगा वही इफेक्ट को सिंपली वी विल कॉल एज Tyndall effect. So the longer the wavelength of light is more transmitted, while shorter wavelength light is more reflected via scattering. तो इसीलिए क्या होता है, as I said, longer wavelength light में ज़्यादा ट्रांसमिशन होगा और इसीलिए स्कैटरिंग की वजह से it will be difficult for precise measurements in turbidimetry, while the shorter wavelength light, जो कम wavelength वाला light है वो ज़्यादा reflect होगा via scattering. That is why for nephelometer it is easier to operate at a 90-degree angle. Now these are just an example of how the solutions will be. You can see we have a purple gold solution, copper sulfate solution, then iron hydroxide colloid. Then see, this is the turbid solution I'm talking about. See this solution here, please follow my laser. This is very clear. But you can see that the solution is turbid. ये turbid है मतलब इसमें undissolved particles है जिसको हमें आइडेंटिफाई करना है, तो हम इसको turbidimetry या nephelometry से आइडेंटिफाई कर सकते हैं. Now, what is the light scattering phenomenon? Now, this is a simple example of our environment around us. Now, we all know air. Air में क्या क्या होता है? We have different gases. Air is a mixture of different gases, dust particles, right? Am I right or no? Then there will be pollen particles which are coming from flowers and all. So the blue color of the sky and the red color of the sun at sunset are basically because of the, we see the blue color of the sun, we see the red color of the sunset hue because of the scattering of light. अभी ये scattering of light किससे होता है? Obviously because in air we have dust particles, we have water droplets, and we have other gases in the atmosphere. So these gases, dust particles, and water molecules, they act as a hindrance to the intensity of light. So that is why in the morning we are able to see the blue color of the sky. हमारे eye के spectrum में हमें वो blue color क्यों दिखाई देता है? Because of this light scattering phenomena. And we can see the red color of the sun at sunset also because of the light scattering. We all know that the light consists of different 7 colors of the rainbow, that is Vibgyor, violet, indigo, blue, green, yellow, orange, red. So when particular wavelength of light is being scattered, तो वो color हमें फिर दिखाई देता है. So this scattering is because in air we have the dust particles. The same phenomena is there, you can see in your sample solution. Sample solution में भी तुम तुम्हारा wavelength of light डाल रहे हो, then उसमें अगर particle रहेगा which is undissolved, so that will cause a hindrance to the path of the light. So that is the reason why there will be scattering and transmission. So this phenomena will help us identify. So when there is scattering, we can identify using nephelometer, and if there is transmission of light, we can identify using the turbidimeter. Now, the efficiency with which the light is scattered will depend upon its wavelength. As I said, longer wavelengths will have less precision, while shorter wavelengths will give you more precise results. So the sky is blue because violet and blue light are scattered to a greater extent than the other wavelengths. So all the colors which are there in the light, that is violet, indigo, blue, green, yellow, orange, red, they all have different wavelengths. So the reason we see the color of the sky blue, क्यों? क्योंकि जो violet और blue light होता है तुम्हारे वो wavelength में, वो ज़्यादा extent तक scatter होता है. So that is why we are able to see that scattered light. So this is a simple example of our environment around us. So is it clear? Everyone has understood? Yes. Shall we proceed? Come on, only 8 students. We can all have an interactive session. At least one of you can please confirm that you have understood this, then I will proceed. I'm going a little slow also. Yes. Okay. Now, nephelometry में क्या होता है? Lesser the concentration, मतलब क्या? जितना तुम्हारा solution में कम suspended particles रहेंगे, that means the concentration जितना less होगा तुम्हारे sample solution में, उतना ज्यादा यूनिफॉर्मली तुम्हारा लाइट स्कैटर होगा, and intensity of the scattered light is going to be directly proportional to this concentration of the sample, which will be measured at 90 degrees. टर्बिडीमेट्री में क्या होगा, जितना ज्यादा concentration होगा, scattering will not be uniform, and in scattering uniform नहीं होगा, haphazard scattering होगा. So because of the haphazard scattering, the transmitted light will be measured more uniformly at 180 degree. क्योंकि अनयूनिफॉर्म स्कैटरिंग नहीं होगा तो स्कैटर्ड लाइट तो हम लेंगे ही नहीं टर्बिडोमीटर में. हम कौन सा वेवलेंथ ऑफ लाइट लेंगे, तो सैंपल से बाहर ट्रांसमिट हो रहा है. तो टर्बिडोमेट्री में इन सिंपल वी कैन ऑपरेट एट हायर concentrations, and nephelometry में we can operate at lower concentrations. So when will you decide whether you have to do the analysis by nephelometry or turbidimetry? क्या समझ में आया, बोलो स्टूडेंट्स, वन ऑफ यू. nephelometry कब करोगे, turbidimetry कब करोगे? Yes. When will you do nephelometry?
जब स्कैटर लाइट को मेजर करना.
You're partially correct. स्कैटर्ड लाइट को मेजर करना है, बट स्कैटर्ड लाइट तो तुम्हारा दोनों में भी हो रहा है, nephelometry में भी टर्बिडीमेट्री में भी. बट फर्क सिर्फ इतना है कि टर्बिडीमेट्री में हमारा जो डिटेक्टर है वो स्कैटर्ड लाइट को मेजर नहीं करेगा, वो सिर्फ ट्रांसमिटेड लाइट को मेजर करेगा. और नेफेलोमेट्री में जो नेफेलोमीटर है वो क्या करेगा, वो सिर्फ स्कैटर्ड लाइट मेजर करेगा, वो एब्जॉर्ब या ट्रांसमिटेड लाइट मेजर नहीं करेगा. कम ऑन, इट इज इन द वेरी फर्स्ट सेंटेंस व्हेन यू विल डू नेफेलोमेट्री, व्हेन यू विल डू टर्बिडीमेट्री. Okay, I will tell you. When you have to operate at lower concentration levels, like when you have diluted samples or when the sample amount is very less and if you have to identify it, then the technique of choice that you will use is nephelometry. क्यों? क्योंकि वो कम से कम concentrations को भी detect कर सकता है. टर्बिडीमेट्री का फायदा क्या है कि वो ज्यादा concentrated solutions को detect कर सकता है. So whenever you have a very heavy sample, very heavy colloidal suspension, and when you have a very light suspension, so light suspensions जो होगा वो उसके लिए तुम nephelometry use करोगे. Why? Because the number of undissolved particles is comparatively less, and it is going to give you better analysis via nephelometry. And if you have a very highly concentrated sample solution, like a suspension is very थिक और थिन सस्पेंशन कब होंगे, जब अनडिसॉल्व्ड पार्टिकल्स तुम्हारे सस्पेंशन में ज्यादा होंगे, दैट टाइम यू गेट अ थिकर सस्पेंशन. And when you have a less amount of undissolved particles in your sample solution, then you will get a lighter suspension. So lighter suspensions can be analyzed using nephelometry, while heavier suspensions can be analyzed using your turbidimetry. So now is it clear how you will choose nephelometry or turbidimetry? Clear है अभी? Yes. Okay. So let us proceed now. Now there is a correlation between turbidimetry and colorimetry. So measurement of the intensity of light transmitted through a medium, where the light intensity is decreased, while nephelometry and colorimetry may measurement of scattered light at 90 degrees. So I will let you know this a little when I proceed. ये थोड़ा अभी तुम लोग को समझेगा नहीं. So let me just proceed with the slide, then you'll understand this concept better. So this is the basically the similarity between a colorimeter and a turbidimeter. Can you anyone tell me what is colorimeter? नाम से क्या पता चलता है तुम लोगों को? What is colorimeter? Have तुम लोगों को है बायो केमिस्ट्री प्रैक्टिकल्स है तुम लोगों को अभी? I think in second year we have biochemistry practicals. चेतन, you're partly correct. कलरीमीटर में क्या होता है, तुम्हारे कलर जो सोल्यूशन में जो कलर है उसको डिटेक्ट करते हो और उस कलर के इंटेंसिटी से तुम लोगों को पता चलेगा कि कितना concentration of that particular colored sample is present. Various compounds exhibit various colors, like you have yellow color, you have red color solution. You know, rifampicin is a drug which exhibits red color. So rifampicin is one of the category of drugs which is red in color, and you can identify it by using colorimeter technique. Why? Because the intensity of red color. So abhi now, depending on the concentration, अगर मेरा rifampicin drug का concentration कम है, तो मेरे solution का color थोड़ा light red होगा. But if I'm having a very high concentration of rifampicin in my solution, then the color of the solution would be a dark red. So whether the color is light red, dark red or medium red, उससे मैं पता कर सकती हूँ कि कितना concentration. That is, the detector will quantify the amount of rifampicin in my solution. So colorimeter और turbidimeter में फर्क मतलब similarity क्या है? Colorimeter is going to measure the transmitted light, and from that we can understand the intensity of the color, how intense the red color is, and depending on that intensity, we can quantify and find out the concentration of the sample. In turbidimeter, also the same concept is there. Light transmitted is measured. Both colorimeter and turbidimeter are operated at 180 degrees. और turbidimetry में हम क्या करते हैं? कितना ज़्यादा turbidity है वो measure करते हैं. So that is the reason why we can analyze heavily concentrated solutions by turbidimetric analysis. क्योंकि जितना ज़्यादा turbid होगा, उससे हमें पता चलेगा कितना concentration है. कम turbid है तो कम concentration है. ज़्यादा turbid है solution मतलब concentration of your sample is more in that solution. This is the similarity. Now there is a difference in the operation of the technique. In colorimeter, absorption of radiation occurs. You have to the colorimeter finds out the quantity, that is the intensity of how much red solution it is. So that redness of the solution will be detected via the absorption phenomena. क्योंकि वो red color का वो light absorb कर रहा है, that is why the red spectrum of the wavelength is going to be absorbed, and that absorbed light is measured. टर्बिडिमीटर में क्या हो रहा है? तुम्हारा वो लाइट ट्रांसमिट हो रहा है स्कैटरिंग के बाद. तो स्कैटरिंग के बाद जो लाइट तुम्हारा ट्रांसमिट हो रहा है वो टर्बिडिमीटर तुम्हारा मेजर करेगा. So turbidimeter is going to basically measure the transmitted radiation via the scattering phenomena. So when scattering is occurring, part of the radiation is transmitted out of the sample, and that transmitted light which is moving out of the sample, that is going to be measured by your turbidimeter. So this is the difference between the colorimeter and turbidimeter. Now there is a difference between fluorimeter and nephelometer. Now can anyone tell me what is fluorimetry? नाम से क्या पता चलता है? Anyone? What does fluori mean? Come on, anyone has an idea what does fluorimetry mean? Do you know that there are certain colors which exhibit fluorescence? When you say I'm using a fluorescent marker, or if I'm using a neon yellow, neon green, neon pink, neon orange highlighter. So why do we call those colors to be fluorescent? What is fluorescence? Anyone? Yes. See, I will tell you, fluorescence is a phenomenon. There are many compounds which exhibit this kind of a fluorescence phenomenon. I will tell you, Chetan, I know you have no idea. फ्लोरेसेंस स्पेक्ट्रोस्कोपी एक और एक टेक्निक है जो तुम्हारे कंपाउंड के फ्लोरेसेंस फिनोमेना को डिटेक्ट करेगी. नाउ यू नो दैट यूवी चेंबर में तुम्हें नियॉन येलो कलर दिखाई देता है. तो वो नियॉन येलो कलर या नियॉन ब्लू कलर जो अभी आजकल के लाइट बंद करने के बाद यू सी द डिजिटल डिस्प्ले ऑफ द वॉच, यू कैन सी a bright blue or a bright neon color. So those colors are nothing but they are fluorescence colors. So there are certain compounds in your pharmaceutical formulations also which in normal light they will not show any color. But when under certain UV light, when they're subjected to UV light, or maybe in the darkness, when all the lights are switched off, they will give you a sparkle, or they will give you that kind of a fluorescence appearance. जैसे कि अभी when you switch off the lights, तुम्हारे वॉच के डायल में अगर वो फ्लोरेसेंस कलर का एलिमेंट रहेगा तो इट इज गोइंग टू गिव यू दैट फ्लोरेसेंस ग्रीन कलर इन द डार्कनेस. So in the darkness or in presence of UV light, there are certain compounds that exhibit such kind of fluorescence colors. So that is nothing but your fluorescence phenomena. And that instrument which is measuring that color, that is the fluorescence color, तो जो intensity of that fluorescence color को measure कर रहा है, that is nothing but your fluorimeter. Now, why is it included in the slide? Because these two techniques are quite similar to each other. Why? Both the techniques, that is nephelometry as well as fluorimetry, they are both operated at 90 degrees. As I told you, turbidimetry 180 degree पे होता है, colorimeter 180 degree पे होता है, और fluorimetry और nephelometry 90 degree पे होता है. अभी फर्क क्या है? Emitted radiation is measured in fluorimeter. क्यों? क्योंकि वो सैंपल थोड़ा सा लाइट एब्सॉर्ब करेगा और फिर उसके बाद एब्सॉर्प्शन के बाद वो फ्लोरेसेंस कैसे दिखेगा? वो फ्लोरेसेंस कलर हमें इसीलिए दिखाई देता है क्योंकि पार्ट ऑफ द लाइट इज एमिटेड, तो वो एमिशन रेडिएशन की वजह से हमें वो कलर दिख रहा है. सो इन फ्लोरीमेट्री एमिटेड रेडिएशन इज मेजर्ड, बट इन nephelometry scattered radiation is measured. So क्योंकि particles are going to be there in your sample. हाँ, Chetan, you are right. They have an appropriate frequency of the light, so that is why when they are emitted, so that fluorescence color is there. एंड नेफिलोमेट्री में क्या होगा? स्कैटर्ड रेडिएशन मेजर होगा. क्यों? क्योंकि पार्टिकल्स की वजह से तुम्हारे रुकावट आ रही है पाथ ऑफ लाइट में, तो उसकी वजह से स्कैटर. आफ्टर स्कैटरिंग द रेडिएशन ऑफ लाइट, दैट इज गोइंग टू बी मेजर्ड. नाउ व्हाट हैपेंस इन UV मेजर? emitted radiations will have longer wavelength than the incident light. मतलब क्या? तुम एक पर्टिकुलर वेवलेंथ ऑफ लाइट तुम्हारे सैंपल पे इंसिडेंट कर रहे हो या सब्जेक्ट कर रहे हो तुम्हारे सैंपल. अभी जब वो फ्लोरेसेंस फिनोमिना होगा, तो बिकॉज ऑफ द फ्लोरेसेंस फिनोमिना देयर विल बी एन एक्साइटेशन. सो एक्साइटेशन की वजह से जो फ्लोरेसेंस फिनोमिना होगा, so that will be emitted at a comparatively longer wavelength than the initial wavelength of light which is subjected. So ये एक फर्क होता है. लेकिन नेफिलोमेट्री में क्या होगा? जो स्कैटर्ड रेडिएशन या एमिटेड रेडिएशन रहेगा, उसका wavelength is going to be exactly similar to the wavelength of light that you supplied on the sample. Are you getting it? So because there is no fluorescence phenomena in this, there is only scattering phenomena. उसकी वजह से क्या होगा? सपोज तुमने 250 नैनोमीटर वेवलेंथ का लाइट डाला है, तो वो उतना ही रेडिएशन को स्कैटर करेगा जितना उस सैंपल में गया है. जैसे कि if I am supplying 250 nanometer wavelength of light, then it is going to emit the same 250 nanometer wavelength of light only after it has been scattered. So is it clear now? Nephelometry and fluorimetry difference. सबको समझा? Can I proceed? Yes. Anyone has any doubts? Okay. Now let us proceed. Now choice of method, as I said in the earlier slides also, no need to repeat again. ज्यादा concentrated suspensions रहेगा तो turbidimetry वाला method use करोगे. कम concentrated suspension रहेगा तो nephelometry वाला method use करोगे. Now we'll go to the instrumentation. It is a simple basic instrument. We have a light source which is going to supply the wavelength of light. तो उसके लिए कौन सा light source use करोगे? You have tungsten lamp. And when we say tungsten lamp, we are supplying only white light. Now there are different light. There is yellow light, there is UV light, there is IR, that is infrared light. वो सब लाइट की हमें ये टेक्निक की जरूरत है. हमें सिर्फ नॉर्मल व्हाइट लाइट चाहिए, जैसे ट्यूबलाइट में से जैसे व्हाइट लाइट निकलता है वैसे. So tungsten lamp is something very similar to a bulb, which is going to supply you the white light. Now you have filters. Now can anyone tell me why there are filters? See, in the block diagram, there was something called as a lens in the between. After the light source, we had a lens. Now, these filters also act as a lens. Then what is the function of the filters? Can anyone of you tell me? कोई अपना जस्ट दिमाग लगा के कि क्यों ऐसा हुआ होगा, क्यों हमने फिल्टर्स यूज किए? एनीवन? Visible the product? No, that's not true. Okay, I will tell you filter का काम क्या होता है. Everyone use Instagram, right? Most of you use Instagram and there are various filters in it जिस पे तुम फोटो खींचते हो कि नहीं हमें ये वाला फिल्टर चाहिए, ये वाला फिल्टर चाहिए. There's different kind of filters are there, X Pro, Sierra, and all those things. What are those filters basically? See there, the filter effect जो है वो क्या होता है they allow only a particular wavelength of light to pass. So when you're using a black and white filter, they are obstructing the other colors of the light. So that is the reason why the picture is only being seen as a black and white picture. And when you're using different filters like Perpetua, Sierra, तो उसमें से कुछ colors subdue हो जाते, suppress हो जाते हैं. मतलब जो Vibgyor band है उसमें से few colors are suppressed. That is the reason why those colors are not shown in the picture, and only those colors which are not suppressed are being able to see. So these the job of the filter is nothing but when you are supplying light. अभी ये white light तुम supply कर रहे हो. कभी किसी ने सोचा कि white light को एक particular wavelength supply करेगा, लेकिन मुझे अगर सैंपल में सिर्फ 250 या 280 या सिर्फ 300 या 530 नैनोमीटर का ही वेवलेंथ देना है, तो मैं वो वेवलेंथ को कैसे आइसोलेट करूंगी? किसी ने सोचा इस बात को? एनीवन केम? क्योंकि व्हाइट लाइट तो मेरा एक है, मैंने एक बल्ब जला दिया, वो तो एक वाइड स्पेक्ट्रम ऑफ लाइट सप्लाई कर रहा है. तो वो टंगस्टन फिलामेंट से एक वाइड स्पेक्ट्रम ऑफ लाइट, वाइड वेवलेंथ, मतलब रेंज ऑफ वेवलेंथ ऑफ लाइट सप्लाई. तो मैं कौन सा लाइट सप्लाई करूंगी मेरे इसमें? मुझे कैसे समझेगा कि मुझे कितना वेवलेंथ देना है मेरे सैंपल? Obviously, I have when I say that I have to operate at a lower wavelength or I have to operate at longer wavelengths, how will I decide or concentrate the wavelength coming out of the sample? Just very simple. I am going to do with the use of filters. Filter का काम होता है filter करना, filtration. तो filtration में क्या हो रहा है? अगर when you are filtering water or something, you are filtering out the impurities and you are allowing only normal water to filter out. तो सिमिलरली वाइड वेवलेंथ ऑफ रेंज ऑफ वेवलेंथ है, तो जब तुम पर्टिकुलर फिल्टर्स यूज करोगे तो वो वेवलेंथ ऑफ लाइट में से सिर्फ कुछ ही वेवलेंथ ऑफ लाइट को फिल्टर करके तुम्हारे सैंपल तक पहुंचाएगा. So that is the purpose or use of your filters. So in turbidimeter, because we are going to operate at longer wavelengths or something, we have to use a higher wavelength. Then we will use a blue filter. So blue filter क्या करेगा? वो exactly 530 नैनोमीटर वेवलेंथ ऑफ लाइट तुम्हारे सैंपल तक पहुंचाएगा. एनेफेलोमीटर में हम ज्यादा हाई वेवलेंथ यूज नहीं करते. So visible filter एक होता है. So in that the visible range of the spectrum will be there because light has a various range of wavelength. तो हमें अगर सिर्फ पर्टिकुलर वेवलेंथ ऑफ लाइट ही सप्लाई करना है हमारे सैंपल में, then we are going to use the filter. So there are different filters depending upon the wavelength. तो कितना वेवलेंथ चाहिए उसके हिसाब से हम अलग अलग फिल्टर यूज कर सकते हैं. So now you understood what is the purpose of the filter. Anyone has any doubts regarding this? Yes. Come on, let me know if you have understood, then I'll proceed. Okay, so Vishal says he has understood. So now let us proceed. Okay. Chetan is also very clear. Thank you. Next, we will move on to the sample cells. Now, there are different types of sample cells for your analysis. So, अगर तुम turbidimeter use कर रहे हो या turbidimetry analysis कर रहे हो, then the cells are made of either glass or transparent plastic. So you will use a rectangular cell. Everyone knows a rectangle shape. So you're going to use a rectangular shape सैंपल सेल फॉर योर टर्बिडीमीटर। क्यों? क्योंकि हमें इसमें स्कैटरिंग लाइट को मेजर करना नहीं है, हमें सिर्फ ट्रांसमिटेड लाइट मेजर करना है। तो ट्रांसमिटेड लाइट मेजर करने के लिए क्या होता है, इस सेकंड okay, I will go to a blackboard method to explain you this. So this is a rectangular cell which I will use in turbidimeter. Okay, तो उसमें क्या होता है, इंसिडेंट लाइट है जो तुम्हारे सैंपल पे गिर रहा है, राइट, एंड देन ट्रांसमिटेड लाइट जो तुम्हारे सैंपल से निकल रहा है वो एक डिटेक्टर से मेजर होगा. So D is detector, 3 is the transmitter. So a rectangular surface is sufficient. Why? Because light will hit on this one surface and then the transmitted light will be emitted out from the other surface and will be detected in the detector. But in a nephelometer, you will have an octagonal cell. So what is an octagonal? It will be somewhat like this, an octagon. तो octagonal cell क्यों होता है? क्योंकि जब तुम वेवलेंथ ऑफ लाइट सप्लाई करोगे तभी स्कैटरिंग के लिए इट शुड हैव मल्टीपल सरफेसेस प्रेजेंट. So because of the scattering phenomena, it should have multiple surfaces which will allow the light to scatter. So that is why you are going to use a semi-octagonal shaped sample cell. Is it clear now why you're going to use a rectangular sample cell and a semi-octagonal sample cell? क्योंकि हमें इसमें क्या है, तुम्हें टू डिमेंशन में सिर्फ दो ही सरफेसेस दिखता है, एक जिसपे लाइट गिरेगा, दूसरा जिसपे लाइट ट्रांसमिट होगा. लेकिन स्कैटरिंग ऑफ लाइट विल हैव टू अकर फ्रॉम मल्टीपल सरफेसेस. थोड़ा उसको 3D इफेक्ट देने के लिए वी आर गोइंग टू यूज अ ऑक्टागोनल सैंपल सेल. क्लियर एवरीवन? सबको समझा व्हाई वी आर गोइंग टू यूज एन सेमी ऑक्टागोनल फॉर नेफेलोमीटर एंड रेक्टेंगुलर सेल फॉर टर्बिडीमीटर? कैन आई प्रोसीड? Yes. Okay. So that is the reason why we will have rectangular sample cells for turbidimeter and octagonal sample cells for your nephelometer. Detectors. They are just photometric detectors. So what is the job of the photometric detector? टर्बिडीमीटर रहेगा तो वो ट्रांसमिटेड लाइट को मेजर करेगा, नेफेलोमीटर रहेगा तो वो स्कैटर्ड लाइट को मेजर करेगा. So that intensity of transmitted or scattered light will be measured, and obviously we can find out the concentration. Why? Because it is directly proportional to your concentration of the sample. So amount of light transmitted is directly proportional to the concentration of the sample in case of turbidimeter, and the amount of light scattered is directly proportional to your sample concentration. That is the reason why in nephelometer it is also scattered light is going to be directly proportional to your sample concentration. So this is the basic instrumentation. So as I said, we have cells which are cylindrical in shape. That is, you'll have a rectangular cylindrical cell for turbidimeter and octagonal cells for your nephelometer. Now there are different factors which affect your measurement. Now the amount of radiation removed or deviated from the primary radiation beam. Now what does deviated means? Deviation basically means your scattering. So or maybe transmission. So both depend on the concentration. The first factor which is affecting is basically your concentration. So it is given by an equation. Please write it down if you have a pen and pencil because this equation is important. So turbidimetry phenomena, which is depicted as S is log I divided by I0, which equals to KBC. This is an equation. Now what is T is basically transmittance and I by I0 defines your transmittance. मतलब क्या है? The initial, the amount of light transmitted divided by the incident light. So that is your transmittance phenomenon. S signifies nothing but the turbidity of your sample, which is occurring because of the scattering. K is nothing but your turbidity constant. B is the path length. Path length मतलब क्या? तुम्हारे कितने path length में तुम्हारा sample का जो dimension होता है, sample cell का जो dimension होता है, that is going to be your path length. Because path length is also important. जितना ज्यादा बड़ा सेल रहेगा उतना टाइम लगेगा तुम्हारे लाइट को वो सेल से इंटरैक्ट करने में. जितना ज्यादा पतला छोटा सेल रहेगा उतना कम टाइम लगेगा, तुम्हारे पाथ लेंथ कम हो जाएगा फॉर दैट सैंपल टू इंटरैक्ट. And C is nothing but the concentration of the suspended material. So using this equation, you can find out the turbidity of the solution. And if you're finding out the turbidity of the solution, you can find out the concentration of the solution by rearranging the equation. So everyone has written down the equation? Yes? Please write it down. Turbidimetry is nothing but S equals to log I by I0, which is nothing. If you're going to simplify it, this equation, this is not there. The derivation of this equation is not there in detail in your syllabus. So that is why I have not explained it. It is a very big derivation. So you just have to remember the equation. So just A, B, C. So everyone has written this. Can I switch it? Can I switch the slide? Okay, I'm assuming you people have written the equation, so I'll switch the slide. Now in nephelometry, what is it? The equation is given as IS equals to KSI0C, where IS is nothing but the intensity of scattered light. KS is obviously the constant, and I0 is nothing but the incident intensity of light, and C is basically the concentration of your suspended material. So using this equation, you can calculate the concentration of the suspended particles, and you can, because detector क्या करेगा, intensity of scattered light को find out करेगा. So you have these values of intensity of scattered light, then you have the value of incident intensity. So directly you can find out the concentration while applying the empirical constant value. So I'll give you an homework. So what is the value of this K? You have to find out. So in the next lecture, I will ask you what is the empirical constant value. So this is a homework for you. ये जो K value होता है constant, उसका value क्या होता है? Like for pi value, we have a particular value like 4.4 something. So वैसे ये वाले K का value क्या होगा वो तुम्हें find out करना. That's an assignment for you. Okay? So please write this equation down. When I've written, I will switch the slide. Just let me know when you have finished writing, okay? Done? Can I proceed?
Yes, ma'am.
Okay. Now it's set of particle size on scatter. The size and shape of the particles are responsible for scattering because most analytical applications involve the generation of a colloidally dispersed phase in the solution. Those variables that influence particle size during precipitation also affect both your turbidimetric and nephelometric measurements. So in iska hai simple, I will show you on the whiteboard. Okay. Now, suppose I have a small particle. Let me draw it first. I have a small particle. So this is a small particle. So now you can see when the light is incident on the particle, the scattering of the light is going to be symmetric. Why? Because the particle size is small. तो अगर मेरा particle size 1/10 रहेगा, smaller than 1/10 the wavelength of light, then the scattering of light will be symmetrical. Please pay attention. I'm scrolling with my finger, that's why my handwriting is very bad. Please adjust it. Now, ये हो गया मेरा small particle. Now, अगर if I have a little bigger particle, which is 1/4 the size of the incident light, तो क्या होगा? थोड़ा सा बड़ा होता है मेरा, तभी scattering phenomena कुछ ऐसे होता है. क्योंकि obviously ऐसे होगा, so because this is an asymmetrical scatter. क्यों? क्योंकि particle size बड़ा हो गया. तो उससे क्या हो रहा है? तो particle size बड़ा हो रहा है, तुम्हारे incident light जो आ रहा है अब एक surface पे कम interact हो रहा है और scattering का जो surface area वो ज्यादा मिल रहा है. And suppose if I have a very large particle, like suppose I have this much big particle, तो इंसिडेंट लाइट इतना ही है, लेकिन स्कैटरिंग और ज्यादा इंटेंस. So are you getting this? So the band of scattering increases even more. So what happens in smaller particles? Smaller the size, if the particle size is 1/10 the wavelength of the light, then my scattering is symmetrical. And if my particle size is a little larger, that is 1/4 the size of the incident beam, then the scattering is concentrated in the forward direction. So that is the reason why I have an asymmetrical pattern. जो यहाँ पे थोड़ा कम scatter होगा, लेकिन ये surface पे ज़्यादा scatter होगा. And if I have one more larger particles, this is A, B, and now if I have a C type of particle over here, you can see that when the particle is larger than the incident wavelength, अभी इतना wavelength सप्लाई हो रहा है, लेकिन उसके कंपैरेटिवली पार्टिकल साइज देखो कितना बड़ा है, तो उससे क्या होगा, एक्सट्रीम concentration of scattering in the forward direction will occur. So because of this, there is going to be scattering at wider angles. So a phenomena which is there of small particles is more occurring in nephelometric analysis, and this B and C, that is asymmetrical scattering of light, is occurring more in turbidimetric, obviously because your operation angle is also higher, and also in turbidimeter we can identify more concentrated solutions. That is the reason why larger particles will be easier to identify turbidimetry than compared to your smaller particles. So is it clear? सबको समझा? Can I proceed to the next slide? So do you know what is the effect of particle size? So smaller the particle, symmetrical scattering of light, and larger the particles, there is going to be a symmetric scattering of light. So is it clear, everyone? The smaller particles will be easier to identify by nephelometry, and larger particles will be easier to identify by turbidimetry. So moving on, practical considerations is we have the next factor which affects your wavelength. So selecting lambda max, which is nothing but your wavelength. Wavelength is denoted by the symbol lambda. It's very important. It is necessary to avoid radiation that is absorbed by the sample. Why? अगर maximum wavelength of light is absorbed by a sample, so there will be less amount of wavelength of light which will be transmitted. तो अगर कम ट्रांसमिशन होगा तो तुम्हारे डिटेक्शन का spectrum कम हो जाएगा, and that will lead to some problems. So it is very important that what kind of wavelength of light you want to choose is dependent on that. So now these computers which are there that give you the graph or that give you the concentration of the data, they have various softwares in which you can apply multiple wavelengths of light and try to find out in which sample, in which wavelength you are going to get the proper precise results. So for that also sample preparation is very important technique for selection of lambda, that is your wavelength. So scattering is going to be related to the concentration of the scattering particles, particle size as well as the particle shape. You may always not have spherical particles. You have various shaped particles also. You may have octagonal shaped particles, rectangular, you may have some ununiform spheres. So depending on the particle shape also, the scattering phenomena is highly dependent as well as the size. So based on all this, you have to properly select your wavelength. जितना ज़्यादा proper wavelength तुम supply करोगे तुम्हारे sample में, उतने अच्छे से तुम्हारा sample detect होगा. So the intensity of scattered radiation depends upon the wavelength of the incident light. That means the wavelength of light जो तुम तुम्हारे sample को supply करो. So shorter wavelengths are scattered to a greater extent compared to larger wavelengths. So that is why sure you have to choose accordingly whether you want a shorter wavelength for nephelometry or whether you want a longer wavelength. So, wavelength of light is chosen in such a way that the analyte solution does not absorb that wavelength of light strongly. तो ऐसा wavelength choose करना है कि sample उसको ज़्यादा absorb ना करे and more of the light is available for scattering and transmission. So is it clear why wavelength is an important factor? सबको समझा? Let's see. Yes. Everyone understood why the wavelength of light is an important factor? Okay. So now let us proceed. Okay, before we move on to the applications, which is going to be the end of this lecture. Wow, you must be so happy. But wait, let's let me also tell you one more thing which is there, that is the molecular weight of your sample. Now, can anyone just tell me using their general knowledge or maybe your presence of mind कि molecular weight क्यों important होगा ये analysis में? Anyone tell me? Come on, let us have an interactive session. Come on, tell me molecular weight क्यों important है? Molecular weight sample का क्यों important है? Tell me. Hmm? Come on, one of you. Even if it's wrong, tell me. Molecular weight क्यों important है? It's all interrelated to whatever I have taught. Hmm? Okay, let me give you a hint. Will molecular weight be a factor deciding the particle size of the sample? Yes. Is molecular weight going to be a deciding factor for the size of your sample? Come on. Because it increases the resistance of the material. Vishal, you're partly right, but not entirely correct. It's simple logic है. जितना ज़्यादा molecular weight है, उतना ज़्यादा particle का size होगा, right? Because molecules further break down into atoms, atoms break down into ions. So do you agree with the fact that जितना ज़्यादा molecular weight होगा, particle size इसका ज़्यादा होगा? Are you getting the fact? Yes. Chetan is right. It increases the size of the particle. So indirectly, it is जितना ज़्यादा molecular weight होगा, उतना ज़्यादा इसका particle होगा. So there are certain polymers which are there in your samples. Like you have maybe a face wash, or maybe you have a gel. So these gels which are there, these formulations have different types of polymers which give that gel properties. So if you have to identify now the gelling property जो होता है, like suppose if I have to make a antifungal gel, or maybe I have to make a hair gel. So whatever active ingredients that are there, तो उसमें वो जो gelling property जो देगा तुम्हारे formulation को, that also depends upon the particle size of the polymers. So the polymers basically क्या होता है, these polymers swell in presence of liquid, and because of the swelling property they form a gel. So because of this gelling phenomena, so it depends upon the particle size of the polymer. So different particle size of polymers will give you different gels. So higher molecular weight polymers might give you thicker gels, while lower molecular weight polymers will give you lighter, means like जैसे कि अपना सैनिटाइजर होता है वैसे टाइप का जेल. So they might give you thinner gels or thicker gels. So based on the thickness and thinness of the gel is basically decided by the type of polymer which you're using. So basically these polymers, अगर तुम्हें you have to find out the quantity of polymers in your sample or the um, particle size of the sample, then for this also you can use your turbidimetry and nepherometry. So that is why the molecular weight also plays an important role. So you can also identify the concentration of polymers that are there in a sample. Like we have to use reverse engineering. Reverse engineering क्या होता है? Anyone knows how generic medicines are made? Does anyone have any idea? Basically, reverse engineering में क्या होता है? Like suppose I have acquired patent of a formulation of an innovator. Innovator क्या होता है पता है? Innovator is someone who has come up with the original formulation and has come up with that original drug. How? The entire formula, the entire data, the quality control, the pharmacokinetics, pharmacodynamics, entire data of the drug. A generic medicine is someone, a generic manufacturer is a company which has acquired the patent for that particular formulation. And now he has to make a formulation very similar to the innovator, in which ways the bioequivalence of the sample will match. A generic medicine or innovator medicine में क्या फर्क होता है? They try to mimic the quality and the property of the medicine in such a way that there is an almost similar bioavailability. Because if I am using a generic medicines, I should have a reason why I should prefer it over the innovator. So generic medicine में क्या होता है? They make it a comparatively less cheaper than the innovator by reverse engineering. तो क्या करता है? वो तोड़ मरोड़ेगा वो टैबलेट का, वो फाइंड आउट करेगा कि उसने कौन सा एक्सिपिएंट यूज किया है, उसने पेटेंट एक्वायर किया है उस फॉर्मुलेशन को कॉपी करने के लिए, तो वो अपना मॉडिफिकेशन करेगा. मे बी दे विल यूज a substitute for that excipient, which will have a similar effect to the original excipient that is there in the formulation. But the bioequivalence will not be affected. Bioequivalence matlab kya? All the absorption, distribution, metabolism, and excretion profile which is there. So in generic medicine should be bioequivalent to your innovator medicine. Otherwise, there will be no purpose of making it. So obviously, the bioequivalence curve should be similar. So for that reason, reverse engineering में हम क्या करते हैं? हम वो excipient का particle size. Now, if I'm not getting a proper consistency, or I'm not getting proper thickness, or I'm not getting proper hardness, or the proper diameter of the tablet, तो मैं रिवर्स इंजीनियरिंग करके फाइंड आउट करेंगे कि वो एक्सिपिएंट का पार्टिकल साइज कितना था. पार्टिकल साइज जितना कम होगा उतना ज्यादा अच्छे से टैबलेट कॉम्प्रेस होगा, उतना ज्यादा हार्डनेस उसका अफेक्टेड होगा, तो जितना ज्यादा कंप्रेशन होगा उतना ज्यादा the hardness will be there in the tablet. So all this reverse engineering में भी हम ये analytical techniques use कर सकते हैं, where we can find out the particle size of the sample, we can find out the molecular weight of the sample, the amount of polymers used, the amount of excipients used. So that is one of the applications. So is it clear? Next, what are the applications? Simple applications. The analysis of water, as Chetan, I think, had said in the initial part. It is used to identify the concentration of ions which are there in your water, and also for clarity. Now you have HPLC grade water, like the amount of water that you use, the quality of water that you use. सबको पता है इन्वर्टर में हम डिस्टिल्ड वाटर डालते हैं, हम लोग नल का पानी नहीं डालते इन्वर्टर में. If you people have inverter and you have to refill the batteries with water, you have to put distilled water in. So there is a reason why we are using distilled water, because there is a difference between tap water and distilled water, where in distilled water some of the ions are removed. So those ions may affect the electrical conductivity of the inverter battery. So that is the reason why we are using distilled water and not tap water, because tap water will have many elements which are not required. They'll have multiple ions, they will have microbial content, they will have hardness, causticity, maybe it will be hard water or soft water. So depending on that, analysis of water is also done using nephelometric and turbidimetry. Obviously, municipality के पानी में तुम देखोगे और बारिश के पानी, a huge difference. You will get muddy water which will come, which is supplied by the tanker, but municipal water is comparatively filtered and pre-treated. So the municipal water which is supplied to our homes is comparatively cleaner than the ones which the tankers bring. So that is also the difference. So analysis of water can be different elements, certain water, like suppose you have water in a particular region which have a higher iron content in it. So उसके हिसाब से you can do the analysis of water using this technique. Also, you can determine the carbon dioxide content. Obviously, gases are there; they are also going to help in scattering of light. So they can you can determine carbon dioxide content and determination of inorganic substances like sulfate and barium chloride. Then ammonia in Nessler's reagent, like how much quantity of ammonia should be there in Nessler's reagent. Then amount of phosphorus which is to be there in strychnine, molybdate. So these are all the reagents which are there. So reagent control में भी तुम use कर सकते हो for quality control. Like तुमने बराबर properly वो reagent बनाया है या नहीं बनाया है, उसमें जितना अमोनिया चाहिए है या नहीं, जितना phosphorus चाहिए है या नहीं. Biochemical analysis, as I said, तुम्हारे immunoglobulins के लिए use हो सकता है for IgG, IgE, IgM, and also for identifying hemoglobin, heptaglobins, and all those contents, and also for quantitative analysis, ppm level. Quantitative analysis is nothing but, as all I have explained, सस्पेंशन है तो कितना क्वांटिटी ऑफ ड्रग है, कितना क्वांटिटी ऑफ एक्सिपिएंट है, तो वो सब तुम आइडेंटिफाई कर सकते हो, which is ppm is nothing but your parts per million level. So what is parts per million? So if you're dissolving 1 milligram in 1 milligram of substance in 1 ml of water, it gives you 1000 ppm. That is 1000 parts per million. So it is a unit, which is obviously you will learn when you go to the higher level of your bachelor's degree. So it is not. I cannot say it is a very hello. Students, can you hear me? Was I offline? Did I go offline in the between? Yes, offline चली गई थी क्या? Because I got redirected to this page again. Yes, any one of you student can tell me, was I disconnected from the lecture?
No, ma'am.
No. So अभी तक पढ़ा सबको समझा? So that is all about nephelometry and turbidimetry. So these are the applications. So it can biochemical analysis में you can also identify amino acids, vitamins and antibiotics also. Like you have vaccines and all that. So उसमें कितना IgG, IgA, vitamins कितने या multivitamin tablets. तो उसमें vitamins का भी particle size you can identify because of the scattering phenomenon. You can quantify by the biochemical analysis method. So it can also be used for the air and water pollution also by basically analysis of water. So that is all. So everyone has understood. सबको clear है nephelometry and turbidimetry. Anyone has any doubt? Let us just quickly go through. If anyone has any doubts, I have saved 5 minutes, so you can ask me and clarify. Yes. Has everyone understood all the 5 students which are there online present in this lecture? Okay, Chetan says everything is clear. What about others? Vishal, have you understood? Mihir, okay, okay. So that is all for today. So we can conclude. I hope you understood the lecture and I hope we get to see each other again. That will be all for today. Thank you, everyone. I hope you understood the lecture. Have a nice Sunday, all of you. हाँ, एक मिनट.